Hi, my name is Puneet Jagrala-Pudi. I'm part of the LSI Corporate Strategy Organization. Over the next 30 to 40 minutes, I'm going to walk you through LSI's perspective on the emerging software-defined storage space, and will give you a brief flavor of some of the initiatives we have going on within LSI in this area. This is the rough flow of my presentation for today. I'm going to start with a taxonomy and walk you through a simple framework on how we think about the various technologies, initiatives, and vendors in the space. I will then take the OpenStack framework as a point of reference and walk you through a mapping of our taxonomy in the OpenStack context. From there, I will show you how we expect the impact of software-defined storage technologies to play out across what we call the data center stack within LSI. I will then touch on some future trends and technologies we expect to gain prominence over the next few years, and end with some comments on customer problems we hear about and the solutions we are either scoping or actively working on to help customers as they look to adopt and scale software-defined storage technologies within their data center. So I've said software-defined storage quite a bit already without really defining what I'm talking about. So what is it? Well, as it turns out, it depends on who you're talking to and what they're trying to sell to you. The term is increasingly broad, multifaceted, and nebulous, which is why we break it down into three buckets within LSI. The first bucket is around management and orchestration, and you can think of this as the control and management plane for storage. Over the past several years, we have seen the growth of big data and cloud, where a lot of business value is being derived from an organization's ability to capture, hold, and analyze massive amounts of data, and to be able to spin up infrastructure, platforms, and software on demand as needed. As a result, we have seen the emergence of several new storage-intensive workloads, as well as growth in established ones. What are some of the use cases in this bucket? Well, first, customers see the value in being able to templatize storage personalities based on policies for each of these commonly used workloads. For example, if I know that I'm going to be deploying a web-facing OLTP application, or Microsoft Exchange for that matter, I see the value in being able to use a template that helps me pick a storage configuration and set it up for me. You can think of storage templates as the first use case within this bucket. Secondly, as storage technologies have evolved, new products and vendors have emerged, and we now have storage sprawl within the data center. Customers have and continue to deploy a variety of storage systems and need to manage it with a common abstraction layer. This enables storage federation and is the second use case within this bucket of management and orchestration. Third, as virtualization and cloud deployments grow, IT admins need to provide capabilities such as self-service, usage metering, and provide chargeback or showback based on analytics. So as you can see, all of the use cases in this bucket are around management and orchestration. And the goal is to simplify and provide more and enhanced capabilities to both the IT admin and the IT user. A sample list of vendors and technologies is shown here. Examples of initiatives that fit into this bucket are the Cinder block storage management project within OpenStack, which we'll talk about in a little bit, and VMware's vVols initiative. Another example in the storage systems space is EMC's Viper, which is looking to provide a comprehensive set of storage management and orchestration services that can run over both external storage systems and software running on industry standard servers. Onto the second bucket. This bucket is where we talk more about software-defined storage targeted at block storage and services capabilities, typically used in virtualization and cloud deployments. The big driver for this bucket is, as you might expect, the growth in virtualization and cloud deployments. Virtualization and cloud deployments have specific storage requirements. Firstly, VMs need block storage. Historically, this block storage has been provided with SANs, but newer technologies are emerging, such as vSANs and cloud block storage, that enable better economics and better scalability. These emerging technologies enable you to use software on industry standard servers, which is quite frankly a game changer in this space. Secondly, VMs need certain SLA guarantees from the storage to meet performance needs and use additional data services such as caching, snapshotting, replication, etc. These data services are becoming decoupled from previous monolithic external storage system models and are getting packaged into software that can be deployed on the hosts. I've listed some of the technologies and vendors that are relevant in this space over here, and we in LSI are engaged with several players to enable them. Finally, the third bucket is around providing file and object storage service capabilities. This probably is the bucket that is most impacted by the growth of big data and covers everything from scale-out file systems like Gluster, FS, to object storage like Ceph and Swift, and even specialized systems like HDFS. I will not dive deep into the value prop of this bucket since it's a fairly well-covered space. So the key takeaway is that there are three buckets in the area of software-defined storage. The first is more around orchestration of software, and storage itself may be a traditional storage system or software running on industry standard servers. The second is around block storage services running on industry standard servers, typically for virtualization and cloud deployments. And the third is scale-out file and object storage services, again, software running on industry standard servers. Of course, no framework is perfect. There is some crossover with object systems emulating block capabilities and scale-out file systems providing object capabilities, and so on and so forth. But we think that this is a fairly decent framework for us to use within LSI. I hope that set the stage a little bit. I'm now going to try to make it a little bit real for you by using the OpenStack framework as an example. For those of you who are unfamiliar with OpenStack, there are a few key projects that I'm going to first describe, and then I'll show you how our framework fits in here. OpenStack Nova helps you deploy VMs on servers. That's one of the fundamental pieces of the OpenStack framework. These servers typically have some storage capacity within them, and this capacity can be connected to VMs as, let's say, the boot image or ephemeral block storage. It's ephemeral because once the VM goes away, so too does the storage. For more production deployments, you might need persistent block storage. And this is typically provided through a SAN via an iSCSI interface, or now with a fiber channel interface. Ceph and Gluster are common too in this area, where you might use the block device emulation capabilities in both those projects. The persistent block storage is managed via OpenStack Cinder, which is shown right below the Nova controller in this figure. Each of these storage systems have a Cinder driver, and the Cinder driver lets you manage and orchestrate the storage as needed. The third type of storage in OpenStack is object storage, provided through a REST-based Swift interface. Swift is a standard that is very similar to the Amazon S3 standard that you get from Amazon Web Services. You might use an external storage system like a NAS with a Swift interface, or more commonly use industry standard servers running software like the Swift Object Store or Ceph. And you have various other projects that complete the OpenStack framework. One key project that I want to highlight is Horizon, which provides a dashboard through which OpenStack deployments can be managed and orchestrated. This is a rough layout of the OpenStack framework. Let's see how our software-defined storage taxonomy fits in here. So looking at each of the three buckets in our framework, Cinder and as an extension Horizon provide management and orchestration of storage. So we categorize them into the first bucket. Cinder specifically is looking to provide a common abstraction layer that can be used with any compliant storage system. It also provides the ability to choose storage based on SLA requirements, which fits our definition of bucket 1. The ephemeral block storage is a slightly uninteresting case, but that and the persistent block storage capability fit into the second bucket in our definition. Projects like Ceph, ZFS, GlusterFS, and now Sheepdog are really interesting here, each of them providing block emulation capabilities in a slightly different way. They are looking to provide block emulation as well as block storage services now. So you can deploy a Ceph system and Sheepdog system and do things like snapshotting, and going forward probably different aspects such as caching, mirroring, etc. We think that the cloud block storage is an area where there will be tons of innovation going forward, with probably multiple new projects and players emerging over the next few years. There's a little bit of category creation going on here as well, with the term cloud block storage being increasingly used, and I'll touch on that a little bit later. Our third category is scale-out file and object storage provided through software running on industry standard servers. And Swift, as well as the Ceph object storage and GlusterFS would fit into this description. So bucket 1, management and orchestration through Cinder. Bucket 2, block storage through Ceph, RBD and Sheepdog. And bucket 3, file and object storage through Swift, Ceph and GlusterFS. Now let's talk about the impact of software-defined storage on the data center. At LSI, we use a simple stack to understand how a data center technology or business model maps into the world as we know it. There are 3 components to this stack, and the fourth element is how it is packaged and delivered to the end customer. So starting at the bottom left of this diagram, we have the infrastructure layer, which we define as silicon, hardware, firmware, and everything else below the hypervisor and the OS. Above that, we have the operating system and system management layer, which includes the hypervisors, operating system, and the cluster and cloud orchestration software. Above that, we have the various platform level and application software. So things like Hadoop or a database would fit in right there. This stack is packaged and delivered to customers through multiple routes, including the traditional OEM route, appliances, via the cloud, and direct or self-built, if you are a customer and you have sufficient scale to build your own servers. Given this specific stack, let's look at how we expect it to be impacted by software-defined storage. Starting at the bottom left again, we expect the infrastructure to become more intelligent and flexible, with application awareness coming down to the infrastructure. If you are looking to templatize and enable policy-driven storage, that intelligence needs to be enabled at the infrastructure layer. So we see that happening over the next few years. Also, if you have new management capabilities, these will need to be exposed through either new tools or through new points of integration. For example, OpenStack Cinder. In order to be able to integrate with the OpenStack framework, storage systems need to be able to support the Cinder API. Another example would be EMC's Viper, which provides customers with a new set of tools to manage their storage infrastructure. So if you are looking to scale out or federate across multiple storage systems, you might use EMC's Viper or technologies like EMC's Viper to enable you to do that. Now, applications running on top of software-defined storage will need to be able to take advantage of the underlying capabilities and also absorb the features that might not be available in software running on industry standard hardware. For example, applications might need to be able to deal with eventual consistency of the underlying storage. Also, they might have to handle features like availability, since the underlying storage might have fewer SLA guarantees. Finally, the rise of software for storage is fueling new business models and enables multiple new players in the data center. For example, ISVs like Nexenta, Red Hat, and Inktank now play a prominent role in storage, which was unheard of previously. Customers can purchase software and support from these ISVs and run storage on industry standard servers. Another area that we see growing is around appliances, and I'll touch on that again on a later slide. So as you can see, software-defined storage is probably going to impact all the components of the data center stack, and we think that there are quite a few exciting times ahead. I'm going to talk a little bit about some of these future trends that we expect to evolve over the years to come. One that I'm really excited about and I think has a lot of promise going forward is cloud block storage. Block storage is critical when you're deploying VMs. It's the most commonly used type of storage when in a virtualized environment. However, when you're looking to deploy at massive scale and when you're looking to provide the elastic capabilities of cloud, then doing it or providing that storage capability through software is really interesting. We are seeing some of the early developments today, with Rackspace Cloud Block Storage being one of them, and Sheepdog being a really interesting project in its experimental phases. And we see this specific market segment playing out over the next few years. Another trend that we have seen for the last few years, and we expect to see it gaining momentum going forward, is unified storage. And this might not be purely in a cloud deployment context. It could also be used in places like your traditional storage, where a single storage system or a single storage product provides you file, object, and block storage capabilities. Thereby, you have a single storage platform that can satisfy all your storage requirements. The third trend that we see gaining momentum, and we again see a lot of players emerging in this space, is around converged systems, where you are converging the compute and storage capabilities onto a single platform. For example, you can check out the Nebula demo that they have at the AIS demo floor, where you can see how compute and storage capabilities or storage resources are being combined into a single package. Other examples are the Cisco UCS NetApp FlexPod offering and the VCE vBlock that is provided by combining EMC, Cisco, and VMware software capabilities. So there are a lot of different vectors of innovation going on in this space, and we think that there will be continuing innovation going forward, both in technology as well as in business models that will help customers adopt software-defined storage. So let's talk about some of the challenges that customers face when they're looking to deploy software-defined storage. So at LSI, we have two customer segments. The first is more traditional enterprise and SMB, which is the bread and butter market for most traditional OEMs. And on the second segment, we have the web cloud market, which is the different web scale, hyperscale customers who are growing at a very rapid rate and deploy at scale. Some of the challenges that we have been hearing about from customers in the traditional space are around maturity. So if they're looking to deploy a software-defined storage technology, is it mature? Is it manageable? So can it be used within their specific environment? And is there support? So are there people who are knowledgeable enough to provide support? And is there an ecosystem of vendors who are willing to support these technologies? These are the types of problems that you would expect traditional enterprises to face. On the web cloud segment, the challenges that we hear about are primarily around performance, scale, and work per dollar, which is not very surprising if you look at the evolution of the web cloud segment over the several years. LSI is looking at challenges faced by both these customer segments, and we are working closely with an ecosystem of partners as well as with key marquee customers who are able to provide us the requirements that we can then bake into our products and product roadmaps. So let me talk to you a little bit about some of the initiatives that we have going on across LSI. And I'm going to break this by the three buckets that I defined earlier around management and orchestration, block storage for virtualization and cloud, and scale-out file and object storage. For management and orchestration, we are looking at working with the different software-defined storage layers, such as the orchestration tools within the OpenStack ecosystem, as well as the different ISVs like VMware, Citrix, and Microsoft, and looking at ways in which we can provide integration and do joint development with these different technologies and players. Our goal is to simplify the deployment and configuration of our hardware within your data center, and to enable advanced features like monitoring, alerting, diagnostics, and enable scale. For block storage, especially in the virtualization and cloud context, we are looking at ways in which we can support the different vSANs and virtual storage appliances, and we are engaged closely with the emerging cloud block storage technologies. We are looking at ways in which we can utilize the features that are built into our hardware and expose them to enable better QoS for these software technologies. Also, make sure to check out the demo that we have around scale-out DAS for more performant block storage deployments. Finally, around the scale-out file and object storage systems, we are looking at ways in which we can enable multiple open source projects within the enterprise and improve performance through application or operating system level hinting and being able to cache objects both on the host side as well as on the target side. Also, we are looking at ways in which we can incorporate hardware-based offloading and acceleration of these different software technologies. We have multiple demos going on at AIS, so please make sure to check them out. I'll touch on a couple of interesting demos here, and you can see more at the AIS demo floor. We have a few different demos around shareable DAS. The first is what we are calling a super demo, where we are looking at ways in which you can accelerate storage rebuild times and increase storage performance when you're deploying scale-out file and object storage or scale-out block storage technologies. The other demo around shareable DAS is what we are calling Hawaii internally. It's a project that is targeted at enabling VM mobility across your cluster, while at the same time retaining the performance guarantees that is expected when you're running a virtualized environment in production. We have a 12 gig SAS switch that we are demoing as well, that we are calling Colossus internally. And also, don't forget to check out the demo that we have going on with Nebula, where we are showing pooled storage capabilities in the OpenStack environment. In summary, I would like to reiterate that while the term software-defined storage is somewhat nebulous and evolving, there are a lot of interesting changes going on in this sector. The term is multifaceted and could refer to management and orchestration of storage through software, the storage being either external storage systems or software running on commodity hardware, to software-based block storage targeted at virtualization and cloud deployments, or 3, software-based file and object storage, or any combination of the above. Given LSI's position in the storage industry, we are engaging with customers and partners to enable broader adoption of software-defined storage in the data center. I hope this session was useful to you. If you are interested in learning more, please reach out to us. Thanks.